In this video, I will be explaining a finding derivative of a composite function, and the rule we use for the derivative for the composite function is called a chain rule. So far we learned product rule, quotient rule, and a power rule. This is a chain rule. How the chain rule works? The chain rule works if you have some function within the parentheses and you have exponent. You can do more than two exponent, like 2, 3, 4, 5, 6. So it's really hard to FOIL them. If you have some function to the power 2, then it's easy because it's just a FOILing and you can get the quadratic. But since we have a cube or 4 or 5 or 7 or 8, then it's getting harder and harder to take a derivative because it will take ages to FOIL it. So we're going to use a chain rule. If you have anything in the square root, it's always a chain rule. Any trig function is always trig. Any trig function always chain rule. We use chain rule. Cosine, sine, tangent, cosecant, anything with a trig. If you have a composite function like a function within a function, then you use a chain rule. So these are all the 4 different functions that you are using a chain rule for. Rewrite the function f of s 2x plus 3 to the power 3 as a function in a polynomial form, then find f prime x. We will use this cube. It's like I'm gonna make open them up like 2x plus 3 and then 2x plus 3 again and then 2x plus 3, and then I'm going to FOIL these two together, and then the third one is going to FOIL. So it will take long time, and since the AP test is time test, we need to have something easy. So let's, if the question is talking about rewrite the function, then I am doing that. I'm gonna FOIL this. If I FOIL these two together, I'm gonna get 4x squared plus 12x plus 9. We get 4x squared, 6x, 6 plus 6 is going to give me 12x. They are like terms. 3 times 3 is 9. And then we have a 2x plus 3. Now I'm going to FOIL the 2x plus 3 with it. It's going to give me 8x cubed plus 12x squared plus 24x squared plus 36x plus 18x plus 27. Now we are going to combine like terms. So 8x cubed doesn't have any like terms. X squared become 36x squared, and then 54x plus 27. And now I can take a derivative of this. Now if I take a derivative of this, it's going to be 8 times 3 is 24, and 3 subtract 1 is 2. Then we have 36 times 2 is 72. 2 subtract 1 is 1 plus 54. Just you guys remember this part, okay? Don't forget it. So that's my derivative for this function, and that's my answer. That's what they were asking me. Now, what is a chain rule? A chain rule is if h of x have something like f of gx, like function within a function, then how I will take a derivative of this. It's going to be h prime x. Okay, I call this outside function, like O, outside function. I call this inside function, like an I. So how do we do it? We take a derivative of outside, f prime. We keep inside as it is, times the derivative of inside, which is g prime x. So that's my chain rule. Again, let's try the same question using a chain rule. 2x plus 3 to the power 3. So f of x equal 2x plus 3 to the power 3, and I'm using a chain rule. So according to my chain rule, this 3 is my outside function. This is my inside function. Okay, so outside and inside function. Let's try. Outside derivative, which means 3 jump to the front like a regular power rule, and keep the inside as it is. 3 subtract 1 is 2 times the derivative of inside, which is 2. I'm going to simplify that. 2 times 3 is 6. We can do that. 2x plus 3 whole square stays. Now I can FOIL this easily because it's a 2, so I can do it easily. 2x square means 4x square, plus sign stays, I leave the space, then plus 3 square is going to give me plus 9. In the middle, I have 2 times 3 times 2, 6 times 2 is 12, and x. Now distribute that x there. 6 times 4 is 24x square plus 72x plus 9 is 54, 9 times 6. So I got exactly the same answer what we got in the beginning when we rewrote the question, but it's kind of easy. This was kind of simpler. Now let's do another question. Find the slope of the normal line to the graph of f theta sine square theta when theta is 3 pi 4. Always remember, this is again slope of normal line and normal line slope, and the tangent line slope, they goes back and forth. You have, if they ask you this, then you can get that one and do the reciprocal and opposite. If they ask you this and this one is given, then again get the slope of this and reciprocal and opposite. So always reciprocal and opposite for either one of them when you take it. Now let's take f theta, f prime theta. I'm taking a derivative, but before I take a derivative, always remember the trig function is going to use a chain rule no matter what. Now this 2 means it's a square on the whole thing. Always rewrite this. When the square is on top of trig, like just a trig, not the theta or x or whatever argument we have, then it means that whole thing is a square. If you have something like sine theta square, like the square is on top of theta, and you can't do anything, it's just gonna keep it that way. So I rewrote the question, and now we are using a chain rule that's inside and that's outside. So to jump to the front, keep the inside as it is, and to subtract 1 is 1 times inside derivative. Now if you guys pay attention, I already said that trig is always going to be chain rule. So this is a chain rule too. Again, this is now my outside, and this is in my within a parenthesis theta, the argument is my inside. So take the outside derivative, which is cosine, keep the inside as it is, times the inside derivative, which is going to be 1. So this is how I got f prime theta equal 2 sine theta in cosine theta. Okay, in this question, as you can see, I have 3x squared plus 2 to the power of 3, which means that's my chain rule. Remember, when you have something like this, or you have a square root, or you have something like that, then it means that's my chain rule. So according to chain rule, that's outside, that's inside. So if I'm taking a derivative of prime x equal, and my rule is take the derivative of outside, keep the inside times the inside derivative. So take the outside, 3 jump to the front, keep the inside as it is, 3x squared plus 2, 3 subtract 1 is going to be 2 times the derivative of inside, which is 6x. We just have to fix this around. It's going to be 18x, 3x squared plus 2 whole squared. So that's my answer for this. You can FOIL this out, you can open it up, and then you can multiply with 18x, but it will be the same thing. Now next question, g of x equal square root 2x plus 5, and I told you guys when you have a square root, always change it to rewrite the question, 2x plus 5 to the power half. Now it's a chain rule. I can do the chain rule. It's g prime x equal, this is outside, this is inside, and then outside derivative, jump to the front, keep the inside as it is, half subtract 1 is going to give me 2 times 1 is 2, and then cross multiply like that. So it's negative half. So I got negative half here, times the derivative of inside, which is 2. This 2 cancel out. I'm left with g prime x equal 1 over 2x plus 5 square root because of the negative exponent. So that's my answer. Next question is, I have to rewrite this again because of the cube root. So it's going to be x plus 2. This 2 inside is a numerator, and that outside number is always denominator. So I wrote it down. Now I'm going to do h prime x. Again, this is my outside, and that's my inside. So let's try that. Outside jump to the front, keep the inside as it is. That's x actually. And 2/3 subtract 1. Let's do 2/3 subtract 1. Make sure 3 times 1 is 3, and then cross multiply. 2 times 1 is 2, minus 3 times 1 is 3. It's going to give me negative 1/3. So I got negative 1/3. Times the inside derivative, which is just 1, because x derivative is 1 and 2 is 0. Now everything looks good to me except this negative exponent, so I have to make it positive. So I got 2 up there, 2/3. Then we have times 1 over x plus 2 positive 1/3. Okay, so I have to fix that negative exponent, which I move that to the bottom. All we can do, it's just a simple multiplication fraction, like you multiply straight across. So I got h prime x equal 2 times 1 is 2, and 3x plus 2 1/3, and that's my answer. We can't do anything with it. Now let's rewrite this question. This one is going to, 5 is a coefficient, so it's going to stay there. I'm rewriting it. This whole thing is going to go x square plus 2x and 1/3. Because the exponent on this whole thing is 1. So that's why 1 goes to the top and 3 to the bottom. So now I'm going to take a derivative of that. And again, it's a chain rule. 1/3 jump to the front. This is outside and that's inside. So outside one, it's going to go 5, 4, 3 when we multiply 1/3 and 5. Keep the inside as it is. And you subtract 1 from 1/3. So that would be 3. 1 times 1 is 1. 3 is 3. So you got negative 2/3. So I got negative 2/3 times the derivative of inside, which is 2x. So 2x and plus 2 actually, this one. So this is what I got for the derivative. My derivative is done. I have to just fix it around. Again, I always fix the negative exponent first. So it's going to give me 1 over x squared plus 2x and 2/3 times, actually 2x plus 2 is going to go up here. So let's multiply together straight across. 5 times 2 is 10x plus 10 over 3x squared plus 2x and 2/3. And that's my answer for the f prime. Okay. For this question, if you see this is, we're going to rewrite this. Always when you have a square on top of a trig, make sure that you rewrite it. This square goes on top of the whole thing. Okay, so now take a derivative. I already said that before, trig functions are always chain rule. So g prime x equal, this is outside, that's inside. So 2 jump to the front, keep the inside as it is. Now the inside derivative times inside derivative. Now if you check inside, I have cosine 3x. Don't you think this is again a chain rule? Right? Chain rule within a chain rule. So this is a chain rule again. That's my outside and that's my inside. So outside derivative is negative sign. Keep the inside as it is, times the derivative of inside, which is 3. This is inside, so it's a 3. let's fix it around. I got -6. 2 times 3 is 6, and this negative moved to the front, and rest of the stuff goes like this: 3x and sine 3x. 3x is an argument for the sine and for the cosine, and this is what my answer is going to be. I can't do anything with this. Okay, this next question, we have h of x sine square 2x plus 1, and every time when you have a square on top of a trig, like a sine, cosine, tangent, secant, cosecant, then you have to rewrite it. It means this square applies on this whole thing, like including this argument. This whole thing is square. Now it's a chain rule within a chain rule, because every trig is also a chain rule and a chain rule. So I'm going to go h prime x equal, this is my outside function, this whole thing is my inside function. So I'm gonna move the 2 to the front, keep the inside as it is, sine 2x plus 1, and then subtract 1 from this 2 is going to give me 1 times inside derivative. Now inside is this function. Now according to this function, that's a trig function, and trig function is always a chain rule, so it means this is my outside and that's my inside function. So take the derivative of outside, which is cosine, keep the inside as it is, times the derivative of inside, which is 2. So this is the whole thing. Now I'm done with the derivative. I just have to fix it around. 2 times 2 is 4, and I'm keeping all the rest of the stuff. Sine 2x plus 1 within the parentheses, and cosine 2x plus 1 within the parentheses, and that's my answer for this one. Okay, now that you know big three, rules of differentiation, product, quotient, and chain, let's see how three can be incorporated with each other. Find the derivative of each of the following functions. So if I look at this question, the first thing first, I have to rewrite it. So I'm going to rewrite this 5x times x plus 3 to the power half. I rewrote the square root thing. Now when I look at it, I can see the product rule first, because that's what the product rule says, right? The product rule says this is my f and that's a g. My product rule is f prime times g plus f times g prime. So take the derivative of f. Now let's try that. Take the derivative of f, which is 5. Keep x plus 3 to the power half as it is, which is my g function, plus keep the f as it is, times the derivative of g, which is a chain rule, because half is going to jump to the front, keep the inside as it is, times inside derivative, which is 1 in this case, because x derivative is 1, 3 is going to be 0. So this is what I got so far. Now I have to fix this around. I have 5x plus 3 square root. This one is 5x times 1 is 5x. And I got half times x plus 3, and I forgot this negative half. Okay, so 5x half x plus 3, negative half times 1 is all of that. The negative half means this is going, I'm gonna do one step at a time. Everything stays the same. 5x on the top, 5x times 1 is 5x, 2 goes in the bottom, and also x plus 3 square root goes in the bottom. Now this is a fraction, this is not a fraction, so we have to do least common denominator. So least common denominator, 2 square root x plus 3 times 1 is 2 square root x plus 3. Cross multiply. 5 times 2 is 10. X plus 3 square root x plus 3 square root is going to give me x plus 3, because square root cancel out. 5x times 1 is 5x. So this one became 10x plus 30 plus 5x over square root 2x plus 3. Now, what else we can do with this? I can do 5x and 10x like terms, so 15x plus 30 over 2 square root x plus 3. 15 is a common factor here, so x plus 2, and this one is 2x plus 3 in the bottom. That's all we can simplify all the way. Okay, next question. I have sine and I have an argument which is 2x plus 1 over x minus 3, and this is always going to be a chain rule because it's a trig function. So this is my outside and that's my inside, and if you guys pay attention, when I get to the inside derivative, it's a quotient rule. So let's try g prime x equal, outside derivative is cosine, keep the inside as it is, which is 2x plus 1 over x minus 3 close, and times the inside derivative, which is a quotient rule. So according to the quotient rule, that's f and that's a g. We're going to keep the g as it is, x minus 3 within the parentheses, take the derivative of f, which is 2, minus, keep the f as it is, 2x plus 1, and take the derivative of g, which is 1, everything x minus 3 whole squared, and close. Now the calculus part is done. All we have to do is make sure that we x minus 3, make sure we can multiply. So 2x times is 2x minus 6. This one is minus 2x minus 1 over x minus 3 whole squared. Now what else I can do up here? 2x and 2x cancel out. This is going to give me negative 7 over x minus 3 whole squared. Negative, yes, and this one is going to stay cosine 2x plus 1 x minus 3 as it is. So this is my answer for this one. Let's go for the next question. This one is square root 2x plus 5. I have to rewrite this and then we can answer it. So you have to rewrite that. It's going to give me hx equal 2x plus 5 half over x minus 3. Now it's a chain rule and it's a quotient rule both. Or how can I solve this? If I do for example, let's take a derivative and then we can see what we can do. H prime x, and that's my f and that's g. F is a chain rule. Keep the g as it is, x minus 3. That's what I told you guys, because it's going to go g f prime minus f times g prime over g squared. So I'm going to keep this as it is, take the derivative of f, which is actually a chain rule. So half jump to the front, 2x plus 5 stays inside, negative half times the derivative of 2 inside, which is 2. This is outside, that's inside. So outside jump to the front, which is half. 2x plus 5 inside stays as it is, and half subtract 1 is the negative half. Take the derivative of inside, which is 2. Then I have minus, keep the f as it is, which is 2x plus 5 and a half, and times the derivative of g, which is 1. All the things is x minus 3 whole squared. Now let's fix the numerator. The denominator is kind of leave it alone. The numerator we can fix. So I have x minus 3 times, I have a half, I have a times 1 over 2x plus 5, and that would be a square root because it's a negative. Then I also have 2 minus 2x plus 5 square root. So if we check, all these things are multiplying the one on the top. So x minus 3 times 1 is going to give me x minus 3. And 2 times the square root 2x plus 5 is going to multiply. So they are in the bottom already. Times 2 minus 2x plus 5 square root is going to stay as it is. Now this 2 is multiplying with all of that, right? So I can cancel out this 2 and that 2. I mean, we will be done with it. Then I'm left with x minus 3 minus 2 x plus 5 square root, and I have everything 2x plus 5 square root. Now what else I can do up here? I can, and also I have that x minus 3 a whole square in the bottom, which I ignored it up here, like I was trying to solve the numerator, but you know that x minus 3 whole square is still there. So if I'm going to move this, it's going to be 1 over x minus 3 whole squared. Okay, what else I can do up here? I can multiply straight across, and it's going to be x minus 3 minus 2x plus 5 square root. In the bottom, I got 2x plus 5 square root times x minus 3 whole squared. What else I can figure it out? The square root, I can do the conjugate, or like top and bottom, the 2x plus 5 only. And if I do this, I can cancel out and move them down there and stuff like that. But I think I should leave it alone up here. This will be a long process. If you want to solve it, but I'm gonna leave it alone. Now let's try this one, the graph one. Given the graph h of x, this is my h of x function. That's my h of x function. And then set to the right, find the equation of the tangent. Tangent means derivative, and equation means y minus y1 equal mx minus x1 p of x square root hx, where x is equal -4. Okay, so technically they are asking me to find an equation which is y minus y1 equal mx minus x1. What is the y value? So y1, which means the plug in -4 into, because they're asking for the p of x, so plug in -4 in here, and that will be your y value. I'm going to draw a line so I can do my work here. P -4 square root h -4. This is my h graph. -4 is this. What is the y value at -4? It's 4, so that would be square root 4, and square root 4 means that's a 2. So p -4 is a 2y minus 2. This is what I got here. Next, how do you find the slope? Since they said tangent line, then I have to take a derivative of this. So you take the derivative of p x, which I'm going to rewrite it because it has that square root, which means half. So p prime x equal half, keep everything inside as it is, like a chain rule. Then I got -half times the derivative of inside, which is h prime x. Now let's plug in, and you know we don't solve if we have a x value given. So I'm going to go 1 over 2, and also this is negative exponent, so I can keep it down there like this in the square root, times h prime -4. Okay, now we already know h -4 was 4, and 1 over 2 square root 4 times h prime -4, which we didn't figure it out yet. So what I'm doing, this is 1/4, because 4 is the square root, 2 times 2 is 4, 1/4 equal, after this, 1/4, and h prime -4. This is -4 prime means a tangent, because that's the original graph. So since they are the same, then I'm going to do the secant. 1 down to the right, so -half times -half. So my answer is -1/8, and that's my slope. So -1/8, and I have x minus, which means +4. So this is my tangent equation. Go to the next question. Let f of x, g of x be differentiable functions such that the following values are true. So these are all my values of x, gx, f prime, g prime. Is the graph of each x, f or g of x, which is a chain rule because it's a composition, it's a chain rule, increasing? Increasing means you have to take a derivative or relative max minimum when x is equal 3. Give a reason for your answer. So it's increase, decrease, relative maximum, minimum. We all know we can have derivative equals 0, critical points, and sign chart. But in this case, I'm not making any sign chart because they're exactly giving me at what x value. So x equal 3, which means that when I take a derivative, I'm going to plug in that x equal 3. And we will see if we have increase, decrease, or anything like that. So let's take a derivative of h prime x. Take the derivative of outside. This is my outside function. This is my inside function. So take the derivative of f prime, keep inside as it is, times the derivative of inside, which is g prime x. Now you have to plug in everywhere h prime 3. So I got f prime and I got g3 times g prime 3. What is g3? This is g function, the 3 is 4. So I got f prime 4 times what is g prime 3? G prime 3 is 6. And f prime 4, this is f prime and 4 is 8. So 8 times 6 is 48 and it's a positive, so it means it's increasing. So since you give a reason, so I'm going to say everything in English. H prime 3 is greater than 0, then hx is increasing. At x equal 3. If px is g2x, what is the value of p prime 1? If they are asking p prime 1, what is my p function, which is right here? That's my p function, and I have to take a derivative of it. So I'm going to take a derivative of p prime x, and it's again a chain rule. This is outside, and this is inside. Outside derivative is g prime. Keep the inside as it is, times the derivative of inside, which is 2. Now I don't have to solve. I have to plug in 1 everywhere. So g prime 2 times 1 is 2 times 2. What is g prime 2? This is g prime 2 is negative 1. Times 2 is going to give me negative 2. And in this one, they didn't say reasoning or justification or anything. So I'm going to just leave it alone. Next question. If qx is square root f of x plus gx, what is the value of q prime 4? What does this value say about the graph of qx when x is equal 4? Give reason. So this function, I'm going to rewrite this first. I got qx equal f of x plus g of x, and I got everything half. Now they said q prime 4, so I have to take a derivative of q, which is q prime x, and then derivative is going to be half. Keep everything inside as it is. It's a chain rule, right? And I got negative half times the derivative of inside, which is going to be f prime x. This is not a product, quotient, any rule because they have a plus sign in between. So f prime x plus g prime x, and done. Now I'm going to plug in 4 everywhere, wherever I see x, half. Then I got f4 plus g4, and I still have that negative half, times f prime 4 plus g prime 4. Then we're going to go back and check what is f4 and all of that. f4, this is f4 is 1. So I got half. This is 1 plus what is g4. And this is g, and 4 is 7. 1 plus 4, 1 plus 7. And I still have that negative half times. What is f prime 4? F prime 4 is 8, and g prime 4 is negative 2. 8 and negative 2. This is 8, and this one is negative 2 plus negative 2. Now 7, 1, I got half, and that's 8. And I still have negative half on top of it. I'm going to fix it. 8 subtract 2, 8, 7, and that's a 6. Okay, now we have to fix it around. I got a half. And 8 has a negative exponent, so it's going to go in the bottom and make it positive, and 6 times, which means 6 is going to go up here. 2 times 3, you can solve that, and 3 over square root 8. This is my q prime 4, sorry, q prime 4. Now, since it's positive and we know q prime 4 is greater than 0, then qx is increasing. That's all. If you guys have any questions, please ask. I will help you out.